So, just a quick note for the external class. What we'll be covering today is construction sequencing. Now, with the internal class, I've been through a list of all the separate areas, all the separate sections of the construction for building a 3-bedroom brick veneer house. And now I'll ask all of you if you can open up Excel and get an Excel spreadsheet happening. So, oh, right. Okay. Okay. So what we'll want to do with Excel is get a blank sheet happening like this, and just one row from the top, one column from the side. Type in week 1. Once we've done that, we can grab our little grip edit on the bottom of that box, drag it across, and populate the top.
You can see this here. These two shapes are in very different positions, but using the following
Oh, well, you can populate that to whatever you want. What they represent are the weeks that it takes us to build our house. Now, with a very standard 3-bedroom brick veneer house that's adopting very standard sorts of technology and is being built to, how do I say it, standard dimensions. So dimensions where we're fairly rectilinear, where we're not having compound curves and slopes going everywhere. It's going to be a fairly quick build. We can do that in about 16 weeks. We can even chop that down to 12 weeks if everything aligns perfectly. We may not want to schedule for 12 weeks because that requires everything to align perfectly, but certainly within that 16-week period we can build a house. And that's what we want to set up. So yeah, fill it out to 21 weeks. If you wish, you may or may not use that. We'll see. That gives us a little bit of a buffer. So then, next to week 1, on the left-hand side, type in the word stage. And I think making that bold is a nice thing to do. And also, it's probably a good idea to expand the width of that column. Take a bit more. So we've got to fit in long words like site preparation, etc. So once we get that happening, we think about, okay, what are the stages of our build? What are the steps? What are we going to do first? Out of all of these things we've identified, what's that? Yeah. So yeah, our site preparation. So type that in. And naturally, as follows. How long are we going to spend on our site preparation, do you think? A week? Yeah. A full week? 4 days? Yeah. I guess, actually this stage is much easier to fill out by hand than it is by Excel. But what we can do in Excel is we can provide a shading to a cell like that. So we can go, alright, bang, 1 week. For illustrative purposes, that's very simple. When you're doing this by hand or where you employ multiple columns for each week, you can shade sections and be a bit more specific down to the days. We can do that, but it would also take much longer throughout the lecture to do that, so we won't be doing that today. So we can punch in a week like that. So now that I've got you started on your Excel spreadsheet, you might as well save it somewhere. And if you have, I don't know, do you guys have a repository within the system for all your own stuff? What's that? OneDrive. All right, so you got a OneDrive. So yeah, just pop it there or on a USB if you wish. It's probably a handy thing for you guys to keep into the future. So we'll shrink that down for now. And we'll get back to our slides.
Where it will be saved, like if we are saving the process.
I'm not sure because I haven't been a student at the TAFE for a very long time. Save as. Okay, Microsoft Office OneDrive. Yeah, if it's quick to save, do that. However, if it's not, I think the most important thing is the process here that we walk through the process. But we do need to keep moving on with today. So as you can understand, we don't just build a building in any random sequence. We don't do the excavation and the slab and then do site preparation. We don't go building the roof frame and then build the wall frames. You know, things have to happen in order. We're not going to lay the flooring and then pour a concrete slab. Things have to happen in order, and to ensure that things happen in order and that the whole process works well and is cost effective, we have to produce schedules. So a great way of producing a schedule is through a bar chart, because we can see what activities follow after the other, approximately how long they should take, and then if any activity gets blown out in time, we can shift everything else according to that initial blowout to reschedule our trades. Because with our trades, they're working on several different projects at once. That is the nature of a trading. They've got several things on the boil. They've got things. They're booked into things into the future, and so they're working to multiple bar charts. It is important for us as builders or designers that are managing the project to understand how we can fit those trades in, when we will need them, and obviously for them when they will be needed. So first up, our site identification. So we ensure we get the right lot. We refer to our survey diagrams and our site identifiers such as the survey pegs. Ensure we get the right allotment and determine exactly where the boundaries of that allotment are. The important thing about determining exactly where the boundaries are, well, we want to ensure that we don't build onto somebody else's allotment to encroach upon someone else's allotment. That is a very, very difficult and then also expensive situation to rectify. But we also want to accurately determine the boundaries of the allotment, because typically a building set out is set out with a dimension from a known boundary. And that will be our identifier of exactly where the building is being placed, so in a geographic fashion. So we need to determine exactly what the boundary is. Following this, we're going to need to organise some temporary site facilities. So the tile on the far right, gone are the days where we would just have an auger on the back of a Land Cruiser, and we'd dig a hole and then put a drop loo over the top of it. That cannot, is not allowed anymore, and builders won't have that as their site facilities. So typically what we bring onto site straight away is a chem loo, so a portable loo that can be used during the construction of the building. We might also, and if you see to the far left, we may want to have some temporary facilities on the site for storage equipment. And also we will have site fencing. It is an issue with building sites now, particularly, is that a lot of stuff gets stolen from building sites, and so it's fairly much standard now that site fencing goes up around to protect those things. It also helps cover the builders in terms of liability. If there's anybody who's unauthorised to be on site, it stops them going onto site and being at risk of having an accident, etc. Temporary site fencing also helps to contain rubbish on the site, because as you would notice, a clean site is a safe and functional site, but the building process is still a very messy process. Many things are being wrapped in light plastic, and we get bits of plastic blowing around. Temporary site fencing is great for containing all of that as well, and it acts as a place for signage. So we can have our access to the site, and then we can have all of our safety signage on that temporary fencing. So next, once we've got our temporary site facilities, or temporary facilities on site, or possibly if it's a tight site, we might want to do this first. So we've made that decision. We've identified our allotments, we've identified where everything is going, we know what our site facilities are going to be. Do we have space of putting that stuff in place initially before we bench the site, or do we have to bench the site first and get that on? That's something that we're going to have to decide. And if we flick back to, I'll just make that slightly smaller. So we go back to our Excel spreadsheet. We can modify that accordingly. So we've got site preparation up there, and then following from that we might write temporary facilities. Now the temporary facilities may have to go in week 2. They may be able to go in week 1. We can muck around with that, and we can modify that as we wish. So on this site, can anybody make a decision at what stage are we chucking our temporary facilities? Are they going to go on at the same time as site preparation? Are they going to go before or after? Anybody making an executive decision on that? After. Right, great, easy. Thank you, done. So temporary facilities going on in the second week. So then we have to bench the site. Now benching the site may be simple or it may be complex. Can anybody think of any complexities with benching the site and what issues we'd run into here? Trees, yeah. So trees, the removal of trees, and certainly if we've got significant trees, the removal of significant trees, that's far more complex, and that might blow the whole scenario out. Hopefully we've understood that during the design phase, and we've got that in process to ensure that we can either work around that significant tree, or if we have to remove that significant tree, that we have all the approvals to do so, that we have that all in place. We don't want to be dealing with that once we've already got earth movers booked in and equipment on site. So there's the removal of trees, but the presence of trees may also provide issues in removal of stumps and roots and so on, or the dead wood can be harbouring termites. You know, these can be issues. So the removal of trees. Any other issues that we may strike in benching the site? What's that? Yeah, levelling the ground. What sort of topography are we working with? And how much cutaway are we going to have to do? How much filling are we going to have to do? Any other issues we may encounter?
Yeah, existing buildings.
Go. What's that?
Existing buildings side by, like existing structures.
Yes, yeah. So any adjoining buildings that may have structural issues or ramifications as a result of our work on the site. So we covered dilapidation reports last week, and if we're going to be working in a fashion that is at risk of doing any disruptance to adjoining buildings, we want to get a dilapidation report in place before we start. And then we'll have to ensure that those buildings are protected either by shoring up or prevention of machinery crashing into them, etc. on the site. Other significant issues you might find when benching the site is contamination. So particularly if we're working in a brownfield site, let's say we've got an empty site in Bowden. So we've got this empty site in Bowden. We start scraping away the top of the soil, we can find anything. We'll start uncovering septic tanks, old car bodies, lead, all sorts of things, asbestos, etc. So with a lot of the greenfield sites further out from town, we don't. This is not such a risk, but it's a risk that has to be taken into consideration, particularly when we're working in a city and older industrial areas. So we've got site contamination. We also may have soil conditions which are, problematic in certain weather conditions. And we have to think about that. We have to think, so on a site we've got at Second Valley, the top of the soil there, when it gets wet, is really compressive. So so we went to bring a truck that carried 10 tonnes on the back of it. So we're talking about 15 tonne of machinery. It can only get so far on the allotment before everything started sinking and compressing in. That's going to be an issue. That's going to be an issue for us with bringing in rubble, with bringing in concrete trucks, etc. And so we need to plan for that, and we need to get our processes in place at that site preparation stage. So think about, okay, we're preparing for the building footprint, but we'll also have to be preparing for getting machinery onto site, etc. in other areas. So the way we go about benching the site is, and what we can see in this top left-hand tile here, is we've got a darker layer on the top and a lighter layer on the bottom. Is there any ideas as to why that layer on the top would be darker? And what that soil contains? Yes, maybe more moisture. Typically that top layer of soil will contain organic material. So, decomposed roots and so on. And that organic material is typically compressible. Well, it's both compressible and it can decompose further, lose more of its structure, and we get, over time, the shrinking of the soil or the compression of that soil over time through decomposition. So we will want to get rid of that top layer of soil. Now, it's probably not a good idea to get rid of that top layer of soil completely. If you want to have gardens and things around your house, that's great stuff for growing plants in. And you can take that away, put that somewhere on site, and then have a nice, deep soil, rich soil profile for under your lawn or whatever you've got to be growing. So keep that stuff on site if you can. It's forget the stats now, but does it take 1,000 years or something to produce 1 inch of topsoil? It all depends on climate and location and whatnot. But this stuff doesn't happen quickly. It's a great resource, but we don't want it under the building. So we scrape away our top layer of soil, and then, strangely enough, we bring some soil back in. Except we're not bringing in soil, we're bringing in compactable rubble. Now, Does anybody know what compactable rubble is or has seen compactable rubble? Typically it's the stuff that, well, your good quality dirt roads are made from. Often, typically this orangey sort of colour, but it can vary a lot. The qualities of compactable rubble is it's got fairly large aggregate in there, so aggregate that's sort of from 20 to 40 mil aggregate in there, so a variable size, a good mix of sand and clay in there as well, that when it gets a bit wet and then you run heavy machinery over it or rollers or something, it packs down. It doesn't get as strong as concrete, but it packs down really strong. Once you've compacted your rubble, you wet it down, you've compacted it, try to dig a trench in that with a pick or something, you'll notice your pick just keeps glancing off it. You can get that really hard. And that's the sort of base or the foundation that we want under our house, something that's really solid. And and it's certainly much cheaper than concrete. Depending on where you live, probably about $20 a tonne. So that'll be 0.6 cubic meters, or so $20. So $40 for a cubic meter, let's say. That goes a fair way. So we lay down our compactable rubble, and we will compact that in 150 mil layers. So Abdullah, that's part of your question from earlier on. We don't want to do layers any thicker than 150 millimeters because our compaction equipment typically is not going to compact thoroughly anything deeper than that. So we'll lay it in 150 mil deep, and then run over that. We'll wet it down, run over that with a roller or whatever is required to compact it, and then lay another 150 millimeters and pack that down to the height that's required. Top left-hand corner, I guess everybody knows what one of those are. Yep. No? Alright, sorry. So, okay. That's a laser level. And that has made work on site immeasurably easier. So previously, I think we might, I don't know if we even teach it in TAFE anymore, the use of dumpy levels.
It's in the survey class.
It's still in the survey class, so use of dumpy levels. I think, yeah. I haven't seen one of those on site for a while.
They're all old, they don't work.
Yeah, I guess the benefits in that are understanding the process and getting the idea of how things work. But laser technology has just been going ahead leaps and bounds, and they're becoming really cheap. So it started off, a good quality laser would be sort of $1,500 or so. Now you can get a decent quality laser around $500-600. Most people who are using them regularly can afford to buy one of those. But yeah, the laser technology has just made life so much simpler for doing this sort of thing. For getting that type of pad, that type of foundation within 10 millimeters. Really quickly, you can attach your laser receiver to your skid steer bucket if you wish, and just cruise along, and it will tell you whether you need to raise or lower your skid steer bucket as you're rolling backwards. That sort of thing. Or there are even automatic controlled laser interfaces with your machinery that lift and lower things like graded blades, etc. So that's our laser level, and yeah, so that's making life much easier for this process, but also in the survey area as well. Our combination of laser technology and accuracy of GPS tracking makes it possible for us to be doing automatic contour plans, etc., with the right equipment as well. So just going around a site and pinging heights to a satellite, which gets all recorded as a file, which can be imported into a CAD diagram or a CAD program to produce contour plans. So that's our laser there. So actually, and what I think, I guess it'll make today's lecture very time consuming if we keep flicking back and forth to our schedule. I think we get the gist of how this is rolling. I'll do it once more. So So now we get to our building set out. So type that in here, building set out. Now, any executive decisions as to when we're doing our building set out? Are we doing that in the same week our temporary facilities are arriving? Or after?
We'll do the same week.
So-
I think we can do
Yeah. Alright. We're doing that the same week.
Yeah, 'cause
Great.
it's-
Yeah, cheers, thanks. Alright, so building set out the same week, but it won't take us long to get our toilet on site, our fencing, etc. So I think everybody now understands what's going on here and what the process is. So we're setting out a path for how things are going to happen and when they can happen. Can things be happening concurrently? So we can be doing our temporary facilities while we're doing our building set out, but we can't do our building set out while we do our site preparation. Site preparation has to happen first before we do our set out. However, that being said, I guess specifically with that example, we're going to do some rough building set out before we do our site preparation. So the building set out you see here, we've got strings and pins and what are they called? Hurdles. We're not going to put those in place and then have an excavator and a skid steer and whatever racing around on site. We're going to make a grand mess of anything we've done there. But what we are going to do is we're going to go on site with a spray marker and we're going to mark out roughly, well, within 30 mil or so of where our building is going to be. We're going to get that all marked out in the ground and we're going to mark out the areas that we want to be excavated. And so we're going to get that all marked. We'll do that with spray marker on the site initially. Following that, we've got everything all levelled off. We know what's happening. We're not going to have machinery on site now for a little while. We'll get our steel pins and our string lines set out. Typically, this is the way you're going to see it with your steel pins, and in some areas, like when we're going to set out fairly permanent string lines or fairly permanent marks, we might do that with steel droppers or steel posts, some people refer to them as. Everybody knows, or star picket, people call them star pickets. Everybody knows what one of those are? Yeah, so we've got here we go, here's a couple here. So we've got our hurdle attached to that. But also the most common we use for our set out are our 10 mil rods or our 12 mil rods. So we've got, let's say some 12 mil rod, and we drive those to the ground, and then we set out our string lines once we've got everything nice and clear and level. We will use something like these hurdles in the situation where we need to be picking things, or typically picking things up from the ground in a higher fashion. When you start setting string lines on a very tall steel pin, your steel pin's bent. You lose your accuracy. So if we're setting stuff up high off the ground, hurdles are fantastic, and hurdles are also great if we're not exactly sure where that string line has to go in a horizontal fashion. So we can set our string line around our hurdle and give us the ability to move that string slightly as well. So in some scenarios, we're going to use hurdles. In other scenarios, the steel pins will suffice. Once we do that, we know where everything's going. Then we do the excavation. Of course, we do excavation with what is known as an excavator. Funnily enough, yeah. However, in some instances, that a trencher might suffice for this as well. So has anybody ever seen a trencher? Trencher at work? Yeah, a few people seen trenchers. Yeah, really quick, but a little bit messy. So the sides of your trenches are not particularly neat with your trencher. Whereas with the excavator, with a decent operator, you can get a fairly neat job. Also, what will dictate a neat job is your site preparation, and site conditions, your soil, etc. With really clay soils, you can get fairly messy scenarios like this because your clay breaks away in clumps, particularly if it's dry. It just cracks away in clumps and so on. And excavating in April, May might be a good idea to avoid that sort of thing, but it's not always possible. So it is soil dependent, but it's also site preparation dependent as well. So here we've got a fairly friable type of loamy top to that. That also results in fairly messy trenches. You'll see that the corners of these trenches and the sides of these trenches have all been falling away significantly. So possibly they don't have a decent compacted fill under there. But another type of finish we can do on top of our compacted fill is what's called crusher dust or dolomite. Is there anybody or does anybody have experience with that? Have you seen crusher dust or dolomite previously? It's that typically it's grey in colour with, I guess, sort of up to 5 mil aggregate, tiny little pieces. I'll quickly find some of that on the internet as an image for you. So let's go get a new one happening. There we go. Crusher dust. Images. Yeah.
Yeah, they got that over there where the lights are.
Yeah. Well, they're probably doing paving or intending to do some paving. Yeah. So it's all gone a bit ground. Here we go. It's thought about it for a while. Yeah. So crusher dust, dolomite. That's once you've got your compacted fill down. That makes a great sort of 50 mil deep layer to go underneath your compacted fill. So I'll just quickly draw a cross section of that. So here is our block of prepared foundation for our house. So we've got 50 mil crusher dust. So it's a bit wonky at the top there. I might straighten that up a bit. So 50 mil crusher dust. Let's say 100 mil of compacted rubble, and then under that we've just got our natural soil. I'll just have to use my finger, don't have a razor here. That will give us the ability to do some really nice, neat edges to our trench, because this stuff, once it's wetted down, it stays fairly solid. It doesn't go rock hard like our compacted rubble. We can still chip into it, break it up, shape it, etc. But it stays nice and firm and keeps its shape. So top your compacted rubble with your dolomite. Get back to our page here, and then with a decent excavator driver, you'll get things that look much better than that. All that. So we excavate that, and we excavate our trenches. Now, how the excavator driver's going to navigate that. That's their business and how they'll plan their work. So they excavate those trenches. The fantastic thing about, and you'll see this throughout the whole building process, there are standard sizes for everything, and excavators are no different. With our buckets, we've got a 150 mil bucket, like skinny little thing. We've got a 300 mil bucket. We've got a 450 bucket and a 600 bucket. That one on there, I reckon, is about a 900 bucket. Fortunately, that perfectly corresponds to the width of beams that your engineer is going to specify. So your engineer is going to say, we're going to have 600 wide beams at whatever depth. Fantastic, we've got a 600 bucket on the excavator. So that's how that works. Following our excavation, we're going to have to get in all of our facilities for our sanitary plumbing. What we do not want to be doing is pouring the slab and then doing our plumbing. So we do our first fix plumbing, and you'll notice, well, we've got an interesting thing happening here with our vertical pipes. That's something different, but something you should see on every site is lagging around horizontal penetrations, lagging around the pipes where they penetrate horizontally through beams. That lagging is it's a 10 mil thick, fairly spongy rubber. It's not really soft, so it's not the sort of soft that once you pour wet concrete onto it, it's going to shrink to nothing. You want it to maintain its structure, but you want it still to be fairly compressible. So when your slab starts moving around a little bit and your pipes want to move in the opposite direction, you have that facility for it to do so. So that the lagging of your pipes keeps the concrete away from your pipes, that required distance, so there is that capacity to move. If we don't go lagging around pipes, what we can have happen is our slab moves a bit, our pipe doesn't want to move, and we'll get a crack. And if we get a crack underneath the floor, that is a very big problem. Pipes can be sheathed inside, so you can core out a pipe and you sheath it inside, but this is a very difficult and expensive process. Beyond that, sometimes your options are to decommission a pipe, you cut it off, and you may have to cut through your slab somewhere to run a pipe in another position and link up. But basically, whatever the solution to a cracked pipe on your slab is, typically it's going to be very expensive and very difficult. So lagging around your pipes is something that definitely has to be looked for. So if we're going to go on site, so we've done our design and we've done our specifications. So we say, all plumbing and fixing work, I think it's AS 4500, don't quote me on that, but let's say all plumbing work to be conducted as per AS ... And then you go on site and the concrete is booked for pouring that slab in the morning and there's no lagging around the pipes. You're going to have to say, concrete will have to wait, I'm sorry, we need to quickly get some lagging on all of those pipes before anything starts. So that's an important one to look for. This one's got lagging on vertical sections. I haven't actually seen that before, and I'm not really familiar with what's happening on this particular building. It is a very interesting build. We've got what are called strip footings happening here. That's long strips of concrete or whatever else we want to use as strips. And then we've got a whole lot of starter bars there. So those starter bars, typically they're going to extend through block work. So you're not going to use starter bars with bricks, typically, unless you're going to be doing several leaves of brickwork and core filling. That's probably going to be vesta blocks happening on top of there. And with those vesta blocks, that tells me we're probably going to have a really heavy structure on top of that. So possibly a suspended concrete slab. And that has been designed for a bit of movement, so possibly that's why we have our lagging around our pipes there. But what we should always be looking for is lagging of the horizontal pipes. And if you guys draw me any diagrams of a pipe going through a beam, if you draw me that detail, I want to see you put lagging on there as well. So we've got our first fixed plumbing in place. Got our septic tank installed, etc. And then we've taped off the top of all of our pipe work. Anybody know why we tape off the top of our pipe work? Yeah, dust and stuff. There's something even more atrocious if it gets in there. Any ideas?
Beds.
What's that?
Beds.
Bees?
No, beds.
Birds. Okay, yeah, birds, but it's not the thing I was thinking of. Nah, not the thing I was thinking of. Nah, not the thing concrete. What's that? Yeah, pouring the slab is a very messy process. You do not want to go filling one of your pipes with concrete. That is, that's pretty much game over there. So we tape off the top of all of our pipework, we want to ensure that we don't get any concrete in there, because once a slab is poured, that's pretty much, pretty much final. So after we've done our setting in our pipes, then we go to the stage of putting in all the steel work. So I'll roll back a bit. Well, we've got a picture here, but that's a pretty clear picture as well. Although, any idea of what's missing in that one?
This is a very simple technique, but obviously very useful.
And I know why it's missing, and it makes perfect sense when you see that thing there. But what we don't have in there, which we will have for all of our residential slabs, is there's no vaporproof membrane under that. Now the reason there's no vaporproof membrane for that is that's going to be the footing for something external. So we can see the edge of our house here, so we're not building a house, we're doing something outside. We don't need to stop that. So we get very small amounts of moisture that come through the concrete and create what's called efflorescence, which is just this white, powdery, dissolved salts that come on the top of slabs. And even with the vaporproof membrane, you'll still get efflorescence, particularly in garages and carports, etc. So if you ever see a new build, you go into the carport, you see this white, powdery stuff in a bit of a line. Has anybody ever seen that before? Yeah, some nods. So that's efflorescence. You'll get that whether there's a vaporproof membrane under there or not. It all depends on the sulfates in the concrete, etc., and the moisture levels and so on. And that, in conjunction with atmospheric moisture as well. So you'll get that, but what your vaporproof membrane will stop is getting that on and into the future as the concrete gets older. So we'll set all of our steel work in place. Now that's a pretty busy example of steel work. If I'm to draw a cross section through our slab, now all of a sudden let's change our soil into a slab beam. That's great. All right, got a bit of a jiggy happening there. Right, we're typically going to have, let's say it's a relatively reactive site, but not, let's say medium class soil. We're going to have, and in fact we might have it set up like that, in that fashion as well. We're going to have 12mm bars, top and bottom, with ligatures, and then possibly 1 or 2 12mm bars right at the top there, and then on top of that, our SL72 slab mesh is going to sit there. That's going to stop any cracking in the floor, or it's going to contain cracking to where we want the cracking to happen if we're doing control joints. But that's going to stop the shrinkage of the slab and the cracking involved with that. These guys are going to provide the tensile strength within our beams. That's pretty much the extent of what we would have in a normal sort of slab. In some crazy situations, these might be 16mm bars or 18mm bars. We might have 3 of them or 4 of them, etc. That's for more extreme scenarios. That one there, that's a bit more of an interesting one. They much smaller bars, they look like 8 or 10mm bars, lots of them spread out. Not exactly sure what's happening with that and why. So this diagram, that's far more typical. It's a bit harder for us to see what's going on in that. But what we can see is we've got our vaporproof membrane that's going underneath our slab, and it goes in before our steel work, and we definitely try not to go puncturing that with our steel work. Obviously, it certainly happens. We've got long bars with sharp ends, guillotined ends. It happens. If it happens, we tape over, or we use some more vaporproof membrane to make a patch, etc. Tape it over. With our membrane, it should be lapped 200mm. So 200mm lap, that much, and then taped. you'll see it. This tape is typically grey in colour, and it's fairly stretchy. Sticks fairly well. All of our penetrations have to be taped around as well. So we want. It's a very easy process. It's not. I guess typically it's not highly detrimental, but it's very easy to get things all sealed up well. Your concreters should do that. So we've got our vaporproof membrane down. We put in all of our bars, and then we'll drop in what are called bar chairs as well. So they're little black things. Probably you guys would have seen them about. Driving along, I see them by the side of the road. Concreters chuck them on the back of their truck and they fly off with the wind, etc. So little things that look like this, and they probably a bit of a cut top to them. They might have a little accommodation there or something. That's where our bars sit there, and they'll have another cut through in that fashion for bars to sit like that. I'll bring some in to a lecture later on. So that's the type of thing you get in the middle of a pizza box to hold the softer lid, getting attached to all the cheese on your pizza. Same sort of thing, except much bigger. So we put in our bars, and supported by our bar chairs, and our slab mesh on the top. So this is our slab mesh here, that grid pattern you can see on top of there. So that slab mesh is suspended. Also, it's up to your concreters to go doing the purchasing of that slab mesh, etc. But you should always allow for 2 squares overlap with your mesh, because if you only got 1 square overlap, it does this sort of thing when you're walking around. Because people are going to have to be rushing around on that like mad when it comes to this process here. So we've got to get all of our steel work in place. We've got all of our shuttering for our concrete, or boards, whatever you want to call it, or formwork.
I'm interrupting you. One stage we are missing, that is the termite mesh.
Yeah, great. Thank you.
I see mostly the sites, they need to fix it after the steel fixing before pouring.
Great, thank you. That's really good thing you pulled me up on. So before we pour our concrete, we want to ensure that our termite protection's in place. Well, we can't really do that afterwards. So that might be that we have to spray down the soil. It all depends on your client and your client's wishes. So there's the option of spraying down the soil. Look, I don't think that's the best. I don't think it's great ecologically or for our own health as well. But there's that might be the thing. There are other forms of vaporproof membrane that have termite poison embedded within them. So you've got these sandwich layers, and then in the middle is termite poisoning. So it's all contained in the membrane until the termite goes to eat through it. Termite goes to eat through it, and either dies or is severely put off by doing that. But the thing Abdullah was talking about was the stainless steel mesh. So has everybody heard of Termi mesh before? Yeah, got some shakes in the heads as well. So Termi mesh, it's like fly screen, except it's a really solid, rigid fly screen made of stainless steel. That, and I'll have to bring some of that in as well. So we've got our pipe here, like this, right? That's going, our slab is intended to go across there. What we will do is we'll get our stainless steel mesh, and that will be wrapped around in a fashion like this, and that mesh will be horizontal, but then it will kick up like this on those edges where we're wrapping it around. We try to keep it horizontal, and then a hose clamp goes on there. So, rubber screw type thing. Clamps it really tight around the pipe, so termites can't go underneath this clamp and can't go under there. And with the mesh projecting out sideways into the concrete slab, termites can't follow their way up a pipe and get into your house, or on the outside of the pipe to get into your house. The reason we have to put that Termi mesh around the pipes is because we pour concrete, and that concrete has moisture in it. Now that moisture is lost, and the concrete shrinks a little bit. We put in our slab mesh to control that shrinkage, to stop that shrinkage happening and disperse that shrinkage evenly throughout the whole slab. But what happens is, where we've got our pipes, the concrete shrinks away from that ever so slightly. In some instances, that's enough of a gap for termites to squeeze between the concrete and the pipe. Because obviously when you've got a solid slab, your termites can't go through that, there's no way. But those penetrations, or anywhere you have something solid penetrating through concrete, where the concrete can shrink away as it's curing, that's a vulnerable area. And so you need to wrap that with termite mesh. If you haven't done another form of termite prevention. So thanks for that. That's a very important step not to forget. And it's very important not to forget any of these steps before this happens as well, because once that happens, it's all very permanent. So got our formwork set out, and then it comes to the day of the pour. Typically, your concrete pour is gonna start happening at 7 o'clock in the morning. So the concreters are going to be on site, and they're going to be making noise as soon as they're allowed to make noise. If they were allowed to make noise earlier, they would be there earlier. So they start that process first thing in the morning. The reason they start that process first thing in the morning is because it can take time for the concrete to go off and solidify enough to the point that you get your mechanical trowel on the top. There's not a great deal of hand troweling that happens these days anymore. It's all pretty much done with your mechanical trowel. Just a brief outline of the process of laying your concrete. So your concrete gets pumped in there, and if it's a small job and you can get the concrete truck right up there in a good place to access that, you do it all from the chute, which is a long U-shaped thing that comes out the back of the concrete truck. You've got all these hooks, and you can join them all together and make a fairly long chute. Obviously, when you've got a fairly long chute, you distribute concrete in a wide arc, but you can drop sections off it. So we're dropping the concrete in from the chute, or we use a concrete pump for larger jobs and jobs where we can't get the truck in so close. Concrete pump it's like a large grain auger type scenario where you have a large hopper. The concrete gets poured into that hopper from the truck, and then that concrete is pumped through a pipe, and it's held up by a boom, or if you're lucky, it's held up by a boom. If you're unlucky, it's one of those pipes that goes along the ground and weighs a ton, and you've got to pick it up with your steel handle. That's if you're unlucky. If you're lucky or cash, use a boom, and that boom can be controlled electronically, and you place the concrete exactly where you want. That's a very important thing because concrete's heavy and it's messy. If you go placing piles that are too big in sections, you've got to move that stuff all the way across. But your concreters will, your decent concreters will be all on for that. So you place the right amount of concrete around, and then you got your concrete rake and you move that around and you screed off. So the process goes from getting the right amount in there to your screeding. Following your screeding, you do it with the bull. You flatten off more with a bull float, which is a really big long pole with a flat bar on that. You bull float that off. So we start our screeding, we get it around to about that much, difference from that much variation. Then our bull float gets it sort of within that much variation, like that. And then your mechanical trowel gets it hopefully with, within no millimetres of variation of surface. So it's all about getting that surface finer and finer and finer and finer and finer. And we'll leave it at that for now. Look, I talk about, somebody who knows concrete really well can talk about concrete probably for a week, but we'll leave it at that. Except that what we have up in these top two tiles, we've got void formers happening there, waffle pod slab, or this is our more common form of slab where we trench straight into the soil. There are pros and cons with each. Obviously,
these type of waffle pods are
yes.
most common in New South Wales and in Victoria, especially in Melbourne.
Yeah.
Here people, they mostly go, I have seen some waffle pod in Adelaide,
Yeah.
but it is mostly common because this is more economical in terms of waffle pod.
Yes. Yeah. So this is actually a system designed by South Australian. Strange enough, but as Abdullah was saying, you see it mostly in Victoria, New South Wales. The reason you see it mostly in Victoria, New South Wales is because it can only handle. I can't remember what the Y values of soil are, but you can't use that on a really reactive site. Unfortunately, within Adelaide, we have a lot of really reactive sites. So if you're lucky, you're Class M soil. If you like most of us, you're probably somewhere north of that. So waffle pods are great to use on sites that are not too reactive, but on your really reactive sites, that's pretty much your only option. So,
and one more thing for the legging, we were discussing, legging will apply if the soil is up to mild, it will apply 2 layers of legging.
Right.
And if it is to extreme or the moderate or the high extreme, it will apply 4 layers of legging.
Right. Yeah, great. Yeah, that's the sort of stuff. Yeah, because I've never worked in an engineer's office that specifies concrete slabs, but yeah, Genos do a lot of concrete slabs.
Yeah.
Don't you? That's great information. So do you know your soil classifications and what
Yeah,
cuts
they are lower, moderate,
Yeah.
extreme, high extreme,
Yeah.
and there is one more.
Hey.
They are all in the concrete slab footing specification. They modified.
Yeah.
But if it is more than moderate, we have to apply 2 layers of legging.
Yeah.
If it is more than moderate, extreme or high extreme, we need to apply 4 layers.
4 layers.
Slab legging.
Yeah, and then P class soil, which is problem class soil. Is that still
Yeah.
4, or do we do more once again? Oh, that's probably just going to be 4.
Yeah, maximum of 4.
So maximum is 4, right? So yeah, so 1 layer for low, is it?
No, there will be 2
So
or 4.
2 layers. 2 layers. Okay, so it's always
2
going to be
layers
2
or
or
4
4.
layers. So
Yeah.
20 mm or 40 mm.
Yeah. Fantastic. Thank you. So our waffle pods and our excavated trench approach, and there are various different excavated trench approaches which we may be able to get into later on. So that's our next step. Following on from that, we're going to do our wall framing. So our first fix carpentry. Now, what we're not going to do is book the concreters on Monday and have the carpenters on Tuesday. That should not happen. I think it might have happened maybe more than once. But that should not happen. You really got to give them and there's something you might have some input into as well. I've always been told you've got to give it a minimum of 5 days before you start doing any significant work on top of your slab, and you don't want to go placing any load on that slab before that. Is that?
We need to cure concrete.
Yes.
It is the most important because that will give concrete. In some cases, I don't know here what they are following, but what my studies told me, we need to wait at least 7 days.
At least 7 days. Yeah.
Because I have worked in a ready-mix concrete environment. There we used to take cylinders and cube while pouring the concrete.
Yeah.
We need to make the first test after 7 days to check the compressive strength of the concrete.
Yeah.
And the second test after 28 days.
Yes.
So that concrete should gain strength, but we need to cure the concrete heavily with water or with curing material.
Yeah.
Whichever is the cheaper.
Yeah, great. Thanks for that. So what Abdullah mentioned is curing the concrete as well. Now we'll get into that further when we actually get into the topic of doing slabs and concreting. But what he's talking about is we want to ensure that concrete gets its maximum hardness, its maximum strength. The way we do that is we slow the moisture loss. I don't know if you've ever noticed things. If you put something in the freezer and you freeze it really slowly, you get large ice crystals happening. If you freeze it really quickly, you get tiny ice crystals happening. And that's why if you're buying frozen fish, like blast frozen fish is better than one that's gone in the freezer. And it's the same with the concrete. if we allow that moisture to go out really quickly, we get just a very limited structure happening between our molecules in the concrete. If we slow that moisture loss, if we slow down that process of the concrete bonding, it forms a much better lattice structure, becomes much harder, and that's what we want to do with our curing of the concrete. So we want to slow the moisture loss from our slab. So we get our slab poured down. Now, we've probably got our soil wet down a little bit underneath our vaporproof membrane. That helps keep that section cool, and that's great, and it also helps solidify the top for when you're working on the top. But the area of our concrete which is exposed to the air, we'll either want to cover that with a curing compound, which is a spray-on compound that stops the moisture loss or slows down the moisture loss, or we'll cover it with plastic and wet that plastic down, or we'll just use a very fine spray continuously to wet down the concrete. So there are various different approaches. Typically, concreters are now just using a curing compound straight on the top because it is really quick. So you do all your surface preparation, and then you get your curing compound on the top, and then from where you work, you recommend 7 days before before work on the top. And you always got to confront that sort of tussle between specifiers and engineers who are saying we recommend this amount of time before you work on that, and you're going to get that tussle between the engineers and the project manager who goes, I've had this blowout, I've had that blowout, I've really got to get the framers on site in 3 days or something. Typically, from what I've heard from other students in the class that are working in these fields, your first fix framing, etc., they're allowing that 5 days time. The engineers are saying you should give it that 7 days, and so best practice around that 7 days. You may encounter people getting on there within 5 days. So that has implications then, if I shrink this down, shrink that one down as well, get rid of that. Oh no, I don't want to close it, no. Just get that down. So that has implications on our bar chart that we're setting out there. So we'll do our concrete pour. I won't go through it because we have to keep moving on. But put in there our concrete pour, and then we're going to have a gap. Now, we might fill that gap in with something, or it might be another project that we work on. That is up to the person scheduling. So given our 7 days of our concrete curing, during that process, yes, we do not want to go stacking pallets of Besser blocks on our slab. We do not want to go getting our trusses craned in on that, or you don't want any trusses craned in there anyhow because they're going to get in the way of the wall frames. You don't want your packs of timber craned in and put on top of your slab. Leave your slab alone. All that stuff either has to go on site if you've got space, or if you don't have space, has to go somewhere off site where it can be brought in quickly as it's needed by the timber framers or steel framers. So we get our wall framing up, and typically we need space for our wall framing as well. So we've got our temporary bracing happening on this section here. You'll see the way the timber framers do that. They'll typically construct a wall frame flat on that slab. Because it's a nice, perfectly flat slab, it's going to give them a very straight wall frame. Construct the wall frame lying down, and they'll tip that up and then put in some temporary bracing. So they'll use some spare bits of timber to do some temporary bracing and get that all happening. Get it level and fire in a nail. Then once we've got our wall frames in place, we'll put our roof frames on top of that. Now, if that's truss, that happens very quickly. If it's pitched, it'll happen longer. That will have implications on your schedule. So some house frames I've seen go up. Well, actually, my brother's a carpenter. He doesn't do first fix framing anymore, but with his team, when he was younger, he said he could do a small house with his team in a day. So that's a very quick frame. But tools, modern tools have enabled this the invention of the nail gun and now battery nail guns as well, where you're not having to buy or use or change gas cartridges really quick, and then also get your apprentice on the drop saw to go cutting all your bits. Things can happen on site with your framing very quickly, but of course that's for a very standard house. Once you step out of that standard, you might have to allow a week and a half, 2 weeks or something for your structural framing. That's going to have implications on your schedule, and you're going to have to know when to speak to your carpenters about that for your scheduling. So then our roof framing, that can happen fairly much, well, just following shortly after our wall framing. And then our plumbing first fix. Well, yeah, I called that our initial sanitary plumbing first fix. It's not exactly the second fix plumbing, but it's the first fix through the framing. So we get our plumbers in there. Now that can also happen, so we've got a plumber's first fix and electrical. That can happen consecutively. They're both doing the same type of thing, but it's not a really busy site. It may be them, the one person and possibly an apprentice on site for each of those trades. It's not thoroughly busy, and both of them are doing much of the same thing, which is coring through studs, running conduits and cables and pipes, etc. through. So they're getting all of that electrical gear in place in order for our roof to go on. Well, what happens before our roof goes on is that our gutters go on. The reason for that is you've got some work with your gutters that ends up getting really difficult if you've got your roof in place already. So you're cutting out all the pops and doing all the joins, etc. That stuff typically is done on the ground, and then it's brought up. You get your roof plumbing in place, or your gutters at least in place, and your pops in the gutters, and all your joins done, and your brackets, etc. And then you get your roof on after that. Roof plumbing, and then we may do the roofing before the brickwork, or the brickwork before the roofing. One of those things, or they may happen consecutively as well. If it's a tile roof, you probably do not want any other trades on site while the roof tiling is happening. Has anybody seen a tile roof going on? It is chaos. Well, it's not chaos. They know what they're doing, but there are people cutting tiles, chucking down tiles, going, nah, bad tile, bad. You got stuff typically going everywhere when you're tiling a roof. Don't want other trades on site where that's happening. If it's roof sheeting, that can happen. Depends on the space. You need a lot of space to set out your roof sheets on the ground before they're shot up, but that can happen. So we've got our brickwork happening. Now, brickwork does take time. So we'll allow probably about 2.5 weeks for our brickwork. In that time, we can have some other things going on as well. So we've got our roof covering happening. So let's say we did our brickwork, then our roof covering. We did it in that way. Once everything is, I guess, essentially, once we keep the rain off, and we've got our brickwork up, so our rain and weather can't come in from the sides, then we can start installing other things like insulation. So obviously we need to get our insulation in before any internal linings go in. Once our internal linings are in, then it's too late. Also, actually, and it's a process, or a stage that we haven't covered here, is incorporated within our timber framing, we get our windows in. Our windows have to happen with our timber frame. In some forms of construction, they will happen later, but to keep it simple, for all intents and purposes, our windows go in at our framing stage. Windows, typically we can't just go to the window manufacturer and go, oh yeah, here's my list of windows, I'll buy them now, can you get them on the truck? That's not going to happen. You're going to have to give them at least a month's lead time for your windows. So when you go, all right, yep, sign on the dotted line, we're building this house, first thing you do is you go and buy your windows. So they're ready on site for when your timber rocks up as well. You don't want your windows sitting around on site. I've seen that. That's bad. Hardwood timber windows sitting flat on site in rain for about a week. That's bad, and that's about site management and storage facilities, etc. But you want to get your windows on there when you get timber on there. And also, before we do any of our linings, we're going to want to have our doors in place as well. The house is going to be at a stage which is called lock-up. The reason we want to have our house all closed up before we get our linings on there is that, particularly if it's winter and there's a lot of moisture in the atmosphere, airborne moisture, if we've got those penetrations open, our doors and windows open when we go putting our linings in, they'll soak up too much moisture and they won't be able to do the flushing properly, and we'll get warpage, etc. of our internal linings. So we need to protect our internal linings from the weather, particularly from wet weather. So if you're working in summer and you're very confident about the weather, yes, you may be able to put your internal linings in before your doors and windows. Guarantee that your doors and windows aren't going to be late. But for safety of to ensure you don't destroy your linings should go in once it's at lock-up. Once our linings are in, then we can do our second fix carpentry, so our skirtings and our architraves, and we can also start fitting, like doing some internal fit out with our cabinetry. So for our bathroom, laundry and kitchen and any other built-in cabinetry throughout the house. So cupboards, appliances and fittings. Oh, another thing, we had services. So that relates to our air conditioning and heating and so on. This has to happen during our electrical and plumbing first fix stage as well. When we've got our frame happening, you'll typically, although you typically want that to happen when your roof and your brickwork are in place as well, to keep weather off that equipment. But it will start happening at about that stage. Following on from our cabinetry, and this is also another area where things can be interchanged a little bit. In some scenarios, we'll get our tiling in before our cabinetry. Typically not. Typically we'll get our cabinetry in first and then our tiling. But this may change with the building that you're building and what fit out is going to be. And you may need to have some consultation with your trades in regards to that. So in this case, which is the common case, we've got our cabinetry in place, and then our tiling is going in around that to accommodate that cabinetry. So our tiling, at this stage, we're typically talking about all of our wall tiling, but we're also talking about the tiling of our wet areas, our bathroom and laundry, etc. What we're not talking about are our major living areas, our floor coverings to the larger living areas. Then we've got carpentry second fix. Then we get plumbing second fix. So bringing in our toilets, our baths, etc., hand basins, showers, and the like. Getting all of those installed. And once again, there can be an interplay between the tiling and the installation of those features as well. One notable example that I can see on the bottom right-hand tile here is we've got a shower with a preformed shower base. We're going to want to get that preformed shower base in before our tiling goes in. Following that, we've got our painting. So our painting internally and externally. Then, following our painting, we do our second fix electrical. So we've got all the facilities in place for all those electrical components, and then the outside finishes of our electrical go on top. You know, what we want to avoid doing is, you know, putting a data port on the wall like that, and then the painters having to carefully paint around that data port. We don't. So the way this works is we've got our backing plate there, we've got all the cables in place, it's all taped off so it's not going to get destroyed by the painters. Painters come and paint, and they paint really easily, and you click this face on. Gives you a nice, clean finish to that. And then, following that, and this is not, it's not a typical inclusion of a building contract. It's one of the special inclusions. Our site works. So, what happens a lot? People typically max out their finances for building. This is not an unusual case. So they max out their finances, and the contract will include a building without floor coverings and without any external works. And then that year after they've got into their house, they mainly try to save to get the floor coverings, the curtains, and the landscaping done. That's typically what happens. In other scenarios where you've got a client that has a little bit more money than time, they may want to include all of this on the contract. So you can include site works on that. You can include all your window treatments and your floor coverings, etc., and any other associated works. So let's say this is a fairly comprehensive contract. We include site works. So once the house is all done, actually there's one stage that happens before the site works. So we've done all the stuff inside, we've done all the painting and so on. What do we do before the site works? Any idea? And it's actually in the tile in the slides here, but it's a little bit around the wrong way. What's that?
Cleaning.
Cleaning, yeah. So before, for anybody who's seen the building process, it can be quite messy. Now, there have been a lot of advancements on that. You go to a building site 20 years ago, very messy. Today, not so messy. And you've got skips delivered to site. Stuff goes in the skip, and if it doesn't go in the skip, someone gets a rap over the knuckles for it not going in the skip. And so the site cleanup can be quick and easy. But you get concrete, you get all sorts of stuff around the site. You get broken bits of gyprock and whatnot, and you get people grabbing bits of gyprock out of the skip to put on that mucky clay soil for running in and out of the house. So you've got all that stuff to clean up. So before we do any of the site works, we definitely have to do that external cleanup, and then we'll typically do the internal cleanup as well.
Would you have handover between cleaning and site works?
You'll always have cleaning before you have handover.
Yeah.
But that's a very contract-specific question. So if site works are not included in the contract, well then you'll have handover before you do the site works, and then so you'll have the cleaning done, before that. So we do cleaning or site clearance, and then do our site works, and then then there's our tile for the cleaning. But that's also, and then there's another process in there which is not covered, which is that the client inspection. So we have our cleaning, and then the process of handover includes a walkthrough with the client and a bunch of little red sticky circles. They'll go, oh yeah, look, that screw, that's a shocker, that's a bit. Put a red dot there, work through, place their red dots about the place for things that have to be rectified, for things that haven't been done to standard. That should also be accommodated for both in your financial planning as the builder and in your scheduling as well. Hopefully, throughout the build, your site supervisor will have been very much onto this, and they will, they'll ensure that there are very few defects in place, and that process is quick and easy. If don't have a good site supervisor, that can blow out in time as well, and you're going to have to pull trades back, which can be a very difficult process. So there's that to be included as well. I'll quickly. It's not in the slides, but I'll quickly make mention of it as well. Throughout your building process, typically your contract is going to include what are called progress payments, and so the builder doesn't have to outlay all of the money. So let's say it's a $300,000 build. If the builder has to outlay that $300,000 and then get paid right at the end when all of the identified defects are remedied, that's a very long time for that builder to have all of that money outlaid. And if they're working on several projects, that's going to be an incredibly expensive procedure, and the vast majority of builders aren't going to be able to do that, will not be able to finance that. The way around that is that within your contracts, you have standard inclusions for progress payments. So your first progress payment is on slab pour, then it's on framing, then it's on wall and roofing, then it's for lock-up, and then handover. So you've got those 5 progress payments happening throughout the process. That involves a valuer from the bank coming out, inspecting, okay, yes, everything's been done to a satisfactory standard. We can pay the builder that portion. That should also be included in your scheduling as well. It's an important part of your financial scheduling to know when those progress payments are going to come through and budget around that. So that's our scheduling, and this is our incomplete schedule. As an exercise for you at home, if you wish, you can fill that out yourself and carry that. So everybody now has their schedule in place. However, there is, we had it further up. Sorry. There's a bit of an indicative chart here, and that's our 12-week build. That's a pretty tight build, and so we've got some things that are happening very quickly. So site establishment happening in a couple of days, excavation happening in a couple of days, just encroaching on week 2. Concreting, so that concreting will happen in the day. It has to happen very quickly, so everything has to be very well organised, and that concrete, you're not going to be pouring one section of concrete and then pouring the next section, 8 hours later. It has to happen as a continuous thing. But we've got our 7 days of curing happening there. Our structural carpentry. Okay, complex house. There's a large window of time for our structural carpentry, and also you'll see a large section of time for our brickwork. So almost 2 weeks for our brickwork. That's pretty normal. It might even go longer than that. Roof guttering, 2 days for roof guttering, that's fine. Roof lining, for a tile roof, that's alright. Sheet roof could happen even quicker. Interior lining, joinery, a little bit more time for joinery, metal work. So that's where we've got steel incorporated in our second fix, etc. So we can follow through that. Now that's a tight schedule. It is achievable, but obviously if you get a blowout of one of these things, where typically where you can't have things happening consecutively, that will draw out, and we should really be allowing around that 16-week period for doing all of this, because we have unforeseen events that happen. So, are there any questions in regards to that construction sequence, or anything you may have wanted to say throughout the lecture that you think was missed?
Yeah, during this construction process, do the council come for inspection?
Great question. Yes, they do. So councils have to be notified at excavation stage of footings. So when you're going to get the excavator on site, you've got to let the council know. So the council, once the trenches are dug, they'll come and have a look at that. Well, they may come and have a look at that. They have to be notified, and then it's up to them whether they come or not. Following that, they need to be there at steel fixing, or once the steel fixing is completed. So you have to tell them again about that once again. You have to say, we're getting all the steel put in our trenches. I noticed you didn't come to see our trenches. Maybe you want to have a look at our trenches and steel at the same time. It's up to them whether they come out. Then they also have to be notified at framing. So once the framing has gone in, the council need to see that, the extent of the structural framing. And then that's it. That's all the notification you've got to give to council.
What about the certificate of occupancy, that is sort of that the house is being fit for people to live in? When are they going to issue that?
So they issue that right at the end when everything has been done to compliance. I don't specifically know that for a standard residential house. I assume the builder has to notify the council that everything has been completed as per the contract. Because when you do your building rules consent, you submit all of your contractual information and all your specifications and plans, and then so the council have all of that, and they say, okay, well the house, we've been notified by the builder that the house has been completed as per all the plans that are being plans and specifications supplied. Therefore, it is habitable. And that's an assumption. I make that clear. I'm assuming that's the case because I haven't actually been through that process or looked into that process myself. But when we're building in trickier within the hills or bushfire zones, that gets a little bit trickier because we need to get the CFS out to certify that the site access is compliant before that certificate is issued. And if we have on-site wastewater, we need to have somebody from the council come out and inspect that system as well before it's certified. But for your standard metropolitan area, that may be something as simple as the builder notifying the council. Any further questions? Jim?
Can roof plumbing be done along with the first 6 initial plumbing?
When we're putting in, like once the frame is up, and then certainly it can. Typically, you have actually that's something your partner's a plumber.
He is.
Yeah. Do you have insight? He doesn't do roof plumbing.
No, so he knows how to do it, but usually they're different trade or they're different plumbers.
Yeah. That's my understanding as well. That you get roofers with the appropriate plumbing certification to do roof plumbing, and then you get sanitary plumbers. And although you need the certification for doing both of those, they're typically spread between those two trades. Good question. Any others? Fantastic. All right. So you've got that schedule there for you to use and to muck around with at home, and you've got the example one here as well. Because we have a short amount of time left today, we can also quickly go. Actually, what I will do before I go talking about IH&S, also in regards to that first assignment, I've had some students say that it's been very difficult actually getting hold of forms. There have been some hurdles there, whereby they can fill out a form online, but then they have to put in their electrician and their builder and all these types of things to be able to get that information back. and also I think it was you had the issue with SA Power Networks that you
SA Water.
SA Water that you submitted the form to them and they were going to send it back to you, but they haven't sent it back to you. Sounds like the process of actually getting into these forms and filling these forms out has tightened up a lot since last year. I'm happy with accepting a report from you guys with hyperlinks in there. So saying, look, this takes me to the right. This is where I have to go for that information. So if you're having issues with actually getting those forms, simply providing me with those links saying, this is where I need to go to get those forms. For me, that's enough. I think, yeah, it's great to go through these forms and look at the information you need, because it's okay. Anybody can fill out a form. You can write and you can write neatly and you can read. You can fill out a form, but there may be some information in there which is a little bit technical of nature. That's the sort of stuff I want you guys to be learning and to be experiencing. However, we may be a little bit limited there, and if you are having issues with it.
One more the thing that while filling out the council form for the new development, they asked me for the building code. For that, they referred us either to call the council or visit the council to acquire the building reference.
Right, yeah, okay, so that's for once you've got building rules consent.
That form is saved, so maybe I can go tomorrow and talk to them, tell them that I'm a student, I'm filling this.
Yeah, I think for the purpose of this, don't take this too seriously, and don't harass. Well, harass, but don't go contacting the service providers too much. I think that may cause problems here for the TAFE as well. If SA Power Networks get a whole bunch of calls from students at TAFE saying, I've got this issue with this thing, I need to do this thing for an assignment and whatever, and they're tied up with that, that may come back on us. So, given things are tightening up a little bit, providing me with all the information of where you need to go, particularly, is enough for me, satisfying for that. But if you can get these forms, and you can get these forms in a PDF format or so, without having to harass people, grab it, put it in. That'd be great. And if you can get them in that empty form that you can fill them out by hand and then scan them, that's also fantastic. But if you can't, please just put that in the report. Say that you can't actually get access to those forms. Provide the link, and that's enough for me. Is that all clear? Great. So that gives us 9 minutes to have a quick look at OH&S. Now, yes, you could talk about occupational health and safety for a long time. I probably can't. I typically tend to know what's specific to me and my practice, but the occupational health and safety requirements differ so much between various activities and various practices. The things that are the same is the overriding legislation, and so the Occupational Health and Safety and Welfare Act we've got 1986 up there, but then there have been amendments to that since, and you also have national coordination and consolidation of OH&S legislation. So we've got Safe Work SA, which I've still got that open here. So Safe Work SA is going to be your go-to place for information about safe work practices and what is required for your particular practice and your particular role. Probably the most important thing in there is going to be your codes of practice. So if I click on the codes of practice there, it tells me right at the top, complementing work, health and safety laws, codes of practice provide practical guidance on how to comply with your legal obligations and need to be followed unless you have another solution with the same or better health and safety standard in your workplace. So major organisations will tailor site practices to their specific scenarios. But those codes of practice have been developed by what Safe Work SA consider to be the best approach they can come up with in very standard given scenarios. So that's going to be a go-to place for you. And then there are other further down. So 2014 review of the Work Health and Safety Act SA, that's going to be important to you as well. And work your way through. So there may be some sectors important to you or not. So now the legislation that governs us in South Australia is similar to that of the Northern Territory, Canberra, I think New South Wales, Victoria, and Western Australia. Something like that. So it's becoming very national. So you can expect similarity across states, but you should not take that for granted. There are still some differences between states, and you should check that your codes of practice are the same from state to state. Beyond that, so we've got our legislation and where to go for our information. But a brief overview, or the important aspects of that Act are the chief objectives of that Act are to secure the health, safety, and welfare of people at work. Yes, to eliminate at their source risks to the health, safety, and welfare of persons at work, and to protect the public against risks to health or safety arising out of or connection with the activities of persons or the use of operation of various types of plumbing. So you've got to protect all the people you're working with and all of the public. Now, let's say you're an employer. Your responsibility is to your employees and to the public. If you are an employee, your responsibilities are to your employer. So that can be, you see an unsafe aspect of work, you actually have to notify your employer. You're obliged to do that. If you don't do that, then you've done the wrong thing, and there may be consequences as a result. But as an employee, you are also responsible for the public to ensure that your activities are not endangering any member of the public. As a member of the public, your responsibility is to not place yourself in a dangerous situation, to not endanger somebody at a work site. I see very few opportunities for that, but you might have a scenario where you're walking the dog off a lead, whatever, the dog runs through a construction site where they're working with cranes, etc., and creates disturbance at the pivotal point. These things can happen. Typically, it's not a common thing. But the various different roles that you have dictates what your responsibilities are. Other chief objectives: to involve employees and employers in issuing affecting occupational health, safety and welfare, and to encourage registered associations to take a constructive role in promoting improvements in OH&S. So that's the extent of what we've got in there. You will find also further in Safe Work SA an overview here of the Act and regulations. Does that include? No, so it doesn't include that summary of the owners of a business, the employees. Basically, the owners of a business have to provide a safe workplace. The employees have to ensure that those feedback mechanisms are carried through to inform the employer, and that they don't endanger any other employees, and that they don't use machinery inappropriately. So they have to follow the rules as set out by the employer. Beyond that should be do we have any questions in regards to that? Well, it's all fairly straightforward and fairly clear. But this, along with also union sites, have a great deal of information on OH&S as well, but this is your formal repository of all you need to know in regards to workplace health and safety. So, how are we doing for time? 2 minutes left. All right, you get a